Now we have a situation where y is inversely proportional to x. So that, well, if y is inversely proportional to x, p inversely proportional to q means that p equals k divided by q. So y inversely proportional to x means y equals k over x. We're given the same x and y values that we were for the previous problem. X equals 2, y equals 20 when x equals 2, so we plug in 20 and 2 for y and x respectively. You get 20 equals k over 2, easily solved to get k equals 40. So our proportionality constant for the inverse proportion has k equal to 40. Now let me clarify that this inverse proportion has nothing to do with this direct proportion. You wouldn't have both an inverse and a direct proportion between the same y and x. So I happen to use the same numbers just because the numbers are convenient, but there's no other relationship between this inverse proportion and this direct proportion. They would not occur simultaneously. Okay, well, k is 40, so we rewrite the equation y equals 40 over x. And I put that in, kind of highlighted it, and I probably should have done the same thing over here. Once we get this equation, then this is the rule that we're going to follow until we have a different proportionality situation. And then if x equals 9, what's going to be the value of y? Well, this time we're going to plug in x equals 9 for this x, which is now in the denominator, with a completely different proportionality constant. So we're going to get y equals 40 over 9, which is approximately 4.4. It's actually 4.4 repeating 4s forever. Okay, so this is an instance of an inverse proportion and how we could use it. And there's much more you can do with an inverse proportion or a direct proportion, but we're just trying to get the basics down right now. And we'll observe that unlike for a direct proportion where a bigger x gives you a bigger y, in an inverse proportion, a bigger x, of course x being in the denominator, means that you're dividing this number k, this constant number k, by a bigger number. If x gets bigger, you're dividing k by a bigger number, and a bigger number is not going to go into k as many times as a smaller number would. It's your basic level of your basic understanding. Okay, so bigger x implies smaller y. It's always so because dividing 40 by a bigger number yields smaller result. Now, there's another question. I'm going to leave this up to you to work out, but I'll give you a little hint. It's asking what happens to y if x doubles. Well, y is going to become half as great. You need to prove that. Of course, if you divide by numbers twice as big, you expect to get a result. You expect that number to go into k only half as many times if you have any intuition about division. However, we can prove this algebraically. If x2 equals 2x1, just the same type of thing we did back here, with this proportionality, I claim that you can conclude that y2 equals 1/2 y1 by a very analogous argument. And I would recommend that you make that argument and write out that proof so that you understand what it means to prove something and so that you have a little deeper insight into the nature of these proportionalities.